Hello. In this video, we are going to discuss assignment number 11. Okay. So, okay, see this. Wait a second. Yeah, let's begin. We are going to do first 2A. Okay. So, this is the question. And this is an improper integral because why is it improper integral? Because we are asked something. This is infinite, right? So infinite doesn't really makes. I mean, there's no proper definition of infinite, right? So this is actually improper. Actually, when one of these are the limits are infinite or minus infinite, cases like this we call it improper integral. Okay. There are other cases too, where let's say this thing vanishes or something. Uh, but in this question, this lower limit is going to minus infinity, so that's why it is improper. Okay. So how do we handle this kind of things? Okay. So we will first do. Let's say we will see if we can integrate this from 2 to c, and then the next process will be we will take c to minus infinity. Okay. So let's divide by 4 first. Okay. If I divide by 4, then this will be 2 by 4, and this will be x by 2 square plus 1. Okay. So this thing is there. Mm, okay. And now what to do? This is a half, and this is going to be x by 2 square plus 1. Okay. Now you take, we will use our substitution method. Okay. If you take t is equal to x by 2, then dt will be dx by 2. So you do that. Okay. If you do that, you will get t square plus 1 dt. Okay. And also we will uh, what do I change the limit, integral limit accordingly. Okay. So here you will get 1, and here you will get c by 2. Okay. I am not repeating limit c tend to minus infinity again and again. So I will just write double dash double dash. Okay. So now this will be this is tan inverse. Okay. If tan inverse, then this will be 1, limit will be from c by 2 to 1. Okay. And if you put the limit, this will be tan inverse 1 and then minus tan inverse c by 2. Okay. And now if you take c tend to minus infinity, then this will be minus uh, you know if c tend to minus infinity, then c by 2 also tends to minus infinity. Okay. Hmm. Okay. So now you know this. If this c tends to minus infinity, then tan inverse goes to pi by 2, of course, right? Because just let me draw the picture of tan. Okay. Something like this, right? At pi by 2, it is going to infinite, right? So since this is the inverse, okay, so at infinite, if you go to infinite, it will return pi by 2. Okay. This is graph of tan. Okay. I'm talking about sorry, oh, I said pi by 2, right? Not pi by 2, I meant minus pi by 2. Okay. Okay, we are talking about minus infinite. Tan takes minus pi by 2 to minus infinite. So tan inverse will reverse this. Okay. It will take minus infinite to minus pi by 2. Okay. So this will be pi by, you'll do the calculation, you'll get pi by 4 plus pi by 2. Okay. So this will be the answer. Okay. Uh, I will wait for 2 minutes. Then we'll go to 2B. Okay, so let's move to 2b. Uh, okay, so again, this limit is going to infinite, so this will be an improper integral. Okay, so what we'll do, we'll take b tend to infinity and this integrate this from 0 to b. Okay, now if you integrate this, you will get I'm using this integration by parts. Okay, and I'm going to take integral of e to the power minus t. Okay, and I will differentiate this thing. Okay, so in integration by part, we have one factor that is being integrated, right? So I am going to take e to the power minus t to be that factor, and I am going to differentiate sine t. Okay, so you do this. Okay, and you will find this and this. I think these are all self explanatory. Okay, okay. So here I'm going to use integration by part again. Okay, now I will use integration by part. You'll get this one. Okay, and now what do we do? Mm, this time also I am taking one to be uh, the factor that is going to be what differentiated. I'm going to take that as cos t, and I'm going to integrate e minus t. Okay, so the that is what I'm going to do in integration by part. Okay, so if you do this, you will see this one and again this one, and note that this reduces to this thing. Okay, once this thing reduces to this thing, you will have to note that this factor is again what we were integrating. We what we were integrating all this time. Okay, so I denoted it by I, this I. Okay, so again we got that I thing. Okay, so this is you can take this to be I. Okay, so if you move this I to this side, you will get 2I, and just this thing is remaining. So you'll get this one, and divide by 2. Okay, once you divide by 2, you'll get this one. And thank you. Mm, yeah, not thank you. We are almost done, right? We haven't taken b tend to infinity. Okay, take b tend to infinity. You'll get you can see this. Okay, this is self-explanatory. Okay, sine 0 and this cos 0 is 1. This one will go away. Okay, I see. I think I should have mentioned this. Oh, sorry. Yeah, this one. This 0b. 0b. Uh, Hi. So, uh, I think this one needs a little more explanation. Okay. Okay. See, mm, I need some space. Okay. How do I? Okay. See, uh, sine b by eb. This part. This one I can write. This is 1 by eb. Okay, less than equal to 1 by eb. So if b tends to infinity, then this one goes to 0, right? Okay, this one This one is fine. Okay. Similarly, second one, this minus cos b e minus b. This one also, sorry, not, I've taken eb in denominator. Okay. So this one also goes to 0. Same reason. Okay. Because of this only. Right. You take b tends to infinity. If you take b tends to infinity, then this thing has to go to 0 because sandwich theorem, right? This is 0 and this one also goes to 0, right? And if you take b tend to infinity, so this one will also go to 0. So this one goes to 0, this one goes to 0, okay? And how about this one? This one goes to, this one is sine 0, okay. Sine 0 is 0, right? So sine 0 into e to the power minus 0, this one will go to 0. So now I just have to convince this part. Okay. So this part is going to 1. Cos 0 is 1 and e to the power minus 0 is 1, right? So this one will be 1. Okay. So that explains that explains this b part. Okay. Okay. So what do we do now in this question? You see, there is no case of that lower limit is infinite or upper limit is infinite. We just have a discontinuity, or you can say what this limit, not limit, this function ln x, this actually goes to what? This is undefined at 0, right? So that is going to create problem. Okay. So if you see the graph of ln x, it will be something like this. Okay. So this is your 0. This is graph of ln x. So here in this direction, you can see it is going to minus infinity. Okay. So at 0, it is not defined. Okay. So we are again handled with a thing which is improper. Okay. So what do we do now? Okay. So the problem is at 0, right? So what we are going to do is we are going to take limit c tend to 0 plus. Okay. And we are going to integrate from c to 1 x ln x. Okay. So how about we integrate, we are again going to use integration by parts. Okay. Here we will take the limit c tends to 0 plus later. First calculate this thing. Okay. If you calculate this thing, you will get ln x, and I'm going to integrate x here and differentiate ln x. Okay. uh, we have two things, right? One is, one part we have to integrate, one part we have to differentiate in integration by parts. So that's what I'm saying. I'm going to integrate x. Okay. So you do this, you will find this one. Okay. And now what I will do, this is from 1 and c. Okay. And what I'm going to do now, I'm going to take limit c tends to 0 plus. Okay. So okay. So if you put 1, ln 1 is equal to 0. Okay. And this, so this part vanishes, and this one will be 1 by 4, and then minus ln c, and then it will be c square by 2, then minus this will be c square by 4. Okay, so check this. This one is minus 1 by 4, that is fine. This one is 0. Okay, and if you take c tends to 0, this one will be 0. Okay, so only this part remain and this part remains. Okay, so what do I do now? Okay, this is of the form, can you check? This is from this is like from 0, not this will be again, you see this is going to be minus infinite, right? If you take c to be 0. Okay, ln that part. Okay, and this part c square, this is going to 0, so this is infinite into 0 type, right? So again, we want to find limit. Okay, what do we do now? Infinite into 0, that's something we have to check if this thing can be dealt. Okay, how do we check that? Okay, we are going to use what is called this thing, L hospital rule, or I don't know the actual pronunciation, but this is what we are going to use. Okay, and how do we do? Okay, so you take 2 by c square below. Okay, so I'm going to state this L hospital rule in loose terms. Okay, so some of you are going to take uh, analysis in later courses, math courses, then you will see the precise statement, but here I will do it loosely. Okay, so sometime what's happened is that limit extends to c fx by gx, this thing this is such what happens is this fx or gx, some bad thing happens. Okay, this one is 0 by 0, or this is by infinite. Okay, so then we check if we can handle this using some other way, and we actually do this. Okay, so this is loosely L hospital rule, but what bad thing happens such that we can use this? This will need some time and what do you say? Some mathematical maturity. Okay, so but you can check this book. This okay. There you'll get more information. I'm getting a little off topic, but uh, uh, you cannot use this thing always. Okay, let's just say uh, mm, fx is, let's say, 1, and this is, let's say, gx. Let's take x square maybe. Okay, limit x tends to 0. Okay, then you will get 0, right? Let me think of an example. Okay, this one. Check limit extends to 0. This will be not defined, or it will take goes to infinity, right? But if you apply this L hospital rule, you'll get 0 by 1, right? And that is equal to 0, right? If you differentiate 4, you will get 0. If you differentiate x, you will get 1. Okay, so this one will be 0. Okay, so that is going to create some problem, right? Because this thing 4 by x, if you draw the graph, you will see 4 by x. Wait a second. How will the graph look? Like this. Okay, so you see at neighborhood of 0, this is going to infinite. Okay, and here it is going to minus infinite. But what it is giving is 0. Okay, okay, so no, you cannot apply L hospital rule everywhere. Okay, so what we are going to do is we are going to we won't discuss where it is applicable. You have to read that book. Okay, but yeah, coming back to the topic, you for this case, I'm telling you, you can use this rule. Okay, once you use this rule, you will get 1 by c, and this will be minus 4 by 3. Okay, and what you are going to do is you differentiated this, right? This will be 1 by c, and this will be minus 4 by uh, c cube. Okay, and then you do the algebraic manipulation, you will get c square by 4, and you can take c to be 0. Okay, then you will get 1 by 4, minus 1 by 4. Okay, so this concludes what question number 2 of assignment 11. Thank you. Okay, okay, by the way, yeah, fill that feedback form. Okay, you see, I'm doing it, I'm wasting not wasting, how do I say it, I'm giving so much energy to you. Okay, spending so much energy for you. Please, it's a 2-minute form. Okay, just fill that. I want to actually I will convince your whoever is your professor in the next sem. I will convince him, her, uh, that I'm going to put videos for you in linear algebra. Okay, thank you.